Hi, everyone. I'm Jonathan Berry, founder and CEO of Golioth, and I'm excited to share some news. But first, I want to thank you. Golioth has grown so much over a short period of time, and it's thanks to you, the IoT developer community. Building IoT isn't easy, yet you voted us a leader in IoT platforms and developer toolings quarter after quarter. We appreciate you for that. We did the math on IoT complexity. On the path to build IoT, there are over 4 trillion decisions to choose from across 17 different decision categories, each with their own decision branch. To alleviate this complexity, Golioth has taken some bold steps. This year alone, the Golioth team has launched a ton of new features. In January, we launched the Golioth Data Simulator, enabling cloud engineering teams to generate data that mimics what devices deployed in the field will send to the cloud before they're ready. In February, we combined our SDKs into a single SDK, making it easier to access advanced IoT features from day one. In March, we did away with device limits, giving away device management features away for free with generous free data limits and a friendlier usage-based pricing model. In April, we announced Golioth Pipelines, allowing you to capture data from devices, transform device-native data to a cloud-friendly format, and stream that data to any destination. And we've continued to add new transformers and data destinations every week. We've also continued our commitment to supporting the latest technologies like adding support for Qualcomm hardware and Bluetooth. With each release, Golioth is chipping away at the decision overload, which brings me to our next big thing. It seems like everything you read these days mentions AI. Generative AI is taking the world by storm. And while AI isn't new for the edge or IoT world, it's advancing at breakneck speeds, and businesses are shifting priorities to adopt AI as quickly as possible. That means building IoT is getting a lot more complex. So today, Golioth is making AI on IoT a lot easier to build, manage, and maintain. Today, we'll show you how Golioth is supporting AI on devices, AI for the cloud, and how training works with real-world examples from our customers and partners. I'd like to introduce Chris Gamble, Head of Hardware and DevRel at Golioth, to guide you through Golioth for devices. Chris, take it away.
Thanks, John. My name is Chris Gamble, and I am the Head of Hardware and Developer Relations here at Golioth. And today I'm talking about the expanded capabilities of OTA that's going to enable a new range of features for your AI-enabled embedded devices. First off, let's talk about model management. This is something that enables your devices to not require a full OTA to update to get a new model onto them to detect things at the edge. This means smaller updates. It also means things like not requiring a reboot in order to get these capabilities onto your devices. We're also enabling single and multi-asset releases. So when you do want to send a new device firmware update down to your fleet, you can do that in addition to packaging in your models with it. Our device targeting allows you to slice and dice your fleet so that you can have things like the same firmware running on thousands of devices, but only a subset of them running different models. Finally, you can get fleet-wide insights so that you know that your devices have been updated, which models they're running, and which versions of firmware are working and not working, so that you can push out new updates to have a very efficient, well-run fleet. Now let's go talk to FLOX Robotics, who we chatted with earlier this week about how they're using Golioth AI capabilities to enable wildlife protection and asset protection out in the world. I'm here with Tomas Becklin of FLOX Robotics. Thanks for joining me, Tomas.
Hey, nice to be here. Thanks for having me.
Could you tell me a little bit about what FLOX Robotics is and what your mission is?
Yeah, so our mission is to enable animals and humans to coexist, and specifically keeping animals away from where they could potentially be harmed. Use case would be an airport runway, for example, or a farmer's crop field.
Awesome. Yeah, and so you use electronics, you use AI, you use IoT to kind of put it all together. What is the ultimate action that is taken for the animal to try and protect them in these situations?
Yeah, so our technology first does a detection. So it specifies what type of animal it is, and then run that through an algorithm and produces a sound that's specific to that animal, location, and other types of metadata. And that sound then will repel the animal from the location.
Similar devices I've seen in the past that have done reactive wildlife type things like this implemented a full Linux system. And you're doing this on an embedded system. Could you talk about some of the unique challenges of an embedded system and then how Golioth actually helps with that sort of thing?
Yeah, I mean, each system comes with constraints. And obviously here we have constraints, right? We have bandwidth constraints, probably one of the major ones, but then we have battery life as well. Those I would say are the two major constraints. As far as like the platform goes, I mean, it's amazing what they can actually pack into this small type of units now, as far as, the camera, as far as the onboard compute. So that's been a surprise to me, but also an enabler, right? We could not do this on board maybe 5 years ago, but now you can actually do this in a pretty cheap solution, and something that also our target battery life is at least 6 months, but we believe we can get even more than that. So yeah, I would say the constraints obviously challenging, but I think it in the end also creates better technology, because constraints have you have to actually dig in and solve the problem in a more efficient way. It's easy to just throw compute or at a problem and solve it that way.
Could you talk a little bit about how Golioth kind of enables that pipeline up to the cloud, and then ultimately what you've learned about in working with us?
Yeah. So what it does, it takes away a lot of work for us to manage the networking part, right? We can focus on what we're good at, which is like the hardware, the embedded system part, and then we can focus on the platform part, right? And using Golioth and your SDK, it's a way for us to just easily communicate with the platform in both directions, whether it's doing over-the-air update or pushing data up to the cloud. That's pretty much just solving that problem for us, the networking part.
I'm here with Koray Amikukubai from FLOX Robotics, and we're going to be doing a technical demo on how they capture images and then use Golioth to interact with AI services on the internet.
Today, I will show you how we use Golioth to handle our neural network model management on our edge devices. So for the demo today, I'll show you how we're using this OpenMV RT1062 camera together with a NRF 91 60 DK for the demo, if you can see it here. There it is. So we're using the OpenMV RT1062 MCU because it has great RAM size, so it's much larger than most other on the market right now, which means you can load large neural network model on it, and you also get pretty decent performance. I mean, it's so small, and we're getting pretty good FPS for our use cases anyway. For this demo, we're communicating over UART between the two boards using RPC calls to trigger the OpenMV card to snap an image, and then that image is then being transferred over UART to the NRF card, to this guy, and then that guy uses LTE-M and CoAP protocol to then transfer the image up to Golioth. And then Golioth, we're using Golioth pipelines to then forward the image from Golioth to our S3 bucket. And then up there in our S3 buckets, we can just continue this way to collect a large data set. And then this data set can be used to retrain a new model for new classes, or just optimizing our existing model when we have our devices out in the field and we want to fine tune the models. So for this demo today, we will use hand signs. We'll collect some hand signs, and it's really important to have a good data set. So we'll actually be using the Hagrid data set, which is a great and vast and extensive data set for hand gestures. So we'll use that. But the overall procedure, by following these steps, you should be able to build up a pretty large data set over time without physical access to your edge devices, which is pretty neat, and which is the reason why FLOX is using Golioth for both their device management needs, but also for their neural network model needs. Let's start off. So here you can see some outputs, some stuff that needs to be cleaned up, but it works for this demo. So here, the NRF card is prompting us, is waiting for a button press or a manifest or an OTA update. It's an OTA update we'll use. So when we have retrained our model, we would then upload it as an artifact to Golioth. And then using an OTA update, we would then transfer this TF Lite file. In this case, so this neural network model will transfer that from Golioth as an OTA update to the NRF card, and then the NRF card would then transfer this TF Lite file over UART to the OpenMV card, and we'll have access to our neural network model there. So here we have the OpenMV IDE. We'll start a script, which is simply starting the RPC stuff that you have from OpenMV. So let's press a button. I'm making a thumbs up here. Okay, pressing the button. We're getting some stuff that needs to be cleaned up, but for the demo, this is fine. Okay, great. So we successfully uploaded the image. Let's have a look. here. So let's go and have a look in our S3 bucket to see if we can find our image there. Yep, it's there. So let's have a look at it. Click here and download it. And there you go. That's me just a couple of seconds ago. So if we look at the Golioth console, what does that look like? So right now we were using our wildlife cam number 1. And you can see here how we today, 30th of July, how we just transferred some images up until now. So this is some OTA stuff from before, but you can see the traffic going here. If we then look at our pipelines, you can see here how we just today, we transferred 52 kilobytes to our S3, to our Amazon S3 bucket. I mean, just think about what we just did. We just use a Sapphire-based application, which we know by using Golioth, we can do our firmware updates or OTA updates. We can do our device management needs. But now we also triggered it to snap an image, or we used it to trigger an image collection on an external device. We then transfer this image using LTM and CoAP protocols up to Golioth, and then we sent it to the S3 bucket. And what does that mean? Well, just in the same way that we just looked at here in our S3 bucket at this single image, we can keep doing this for a long time without needing to have physical access to our devices, and we can build up a pretty large data set specific for our needs. And then we can use this data set to train a new neural network, and then we'll show you later how we use OTA updates from using Golioth here to then send this newly trained neural network model to the edge device again. Okay, so I'll show you what we'll do for this demo. So we'll simply use a YOLO V8N CLS network, and we'll retrain it on the Hagrid dataset. It's a pre-existing dataset. I didn't collect this. It's a really good dataset consisting of different hand gestures. So you can see here how we're loading the YOLO V8N CLS network, and then we're retraining it for 100 epochs. What's actually important here when you're working with microcontrollers is to do the integer quantization of your model, because as we all know, they have limited RAM, and using float numbers for all of these weights, well, that's gonna take up a lot of RAM. So you need to transform, or you need to convert all these float values into integer. What we have done is that we train the model and then we export it into TF-Lite format. And this TF-Lite format, we now want to get back to our edge device without actually having any physical access to it. And then we'll use, guess what, Golioth. So we'll upload this TF-Lite file to Golioth, and we'll use an OTA update to get it over there. Okay, so now it's time to get that new TF-Lite file, to get that new neural network that we designed, the new model. We need to get that onto our edge device without physical access. And as I mentioned, this is where Golioth comes into play again. So not only are we using Golioth for our device management needs here at FLOX, we're also using Golioth for our neural network model management too. So you can see here in our artifacts, in the same way as you would do OTA for the firmware of your app, we're handling our different models. So here we have different versions of our YOLO model here, the YOLO neural network. So how do we get this file up then? Or to our edge device. So what we do is we create a new artifact. We select the existing blueprint. We tell, you can be more precise here, but for the demo, this is fine. We're saying that we want to update our YOLO model. And we'll give it a new version, let's say 0.06. And then we upload the artifact. So in this case, that will be the TF-Lite file. So let's see. So we'll find it here. Just bear with me here. We'll just get the correct TF-Lite file. So here we go. Okay. All right. So usually I would, so what you do is you zip your labels together with your neural network or your TF-Lite file here. So that would be this then. And then and then we create a release just like a regular OTA updates. So let's cancel this rollouts. So we create new one. Again, select that, select the beta, and we want to have the correct tags for this, for our wildlife cam. And let's say we pick this, the newest artifact, and that's it. And then we create the release. And here it is. And then we do a rollout. So we have now performed the rollout, and we have now transferred our neural network model to the NRF board. So instead of doing a firmware transfer for the OTA update, we have transferred a neural network model, and we're updating our neural network model. So it's transferred to the NRF board, which is our communication MCU. Okay. So now that we have received the TF flight file, the new neural network model, through the OTA update with Golioth, it's time to try it out. So we'll use the OpenMV IDE for this, just to visualize what we're seeing. So we can just quickly take a look at the script here, what we're doing. So we're loading our this new TF flight file that we just transferred using the OTA update. And then, we're running inference on the images that we're taking with the OpenMV card. So remember, this new TF flight file, this new model is running on the OpenMV card. So it's a microcontroller which is running the YOLO V8N CLS network. So don't expect too high FPS, but it's pretty impressive that we can run this today. I mean, it's things are moving forward pretty fast, so it's cool that we can do this. All right, so let's give it a shot. Let's see what this new neural network model looks like. What's the output? Okay, so there I am. All right, so here we go. Now it's running inference, so we're not doing anything, but what happens if we do this? Confidence goes up. Okay, that's a like. All right, makes sense. You can see down here how the FPS is around 0.6. Let's see if we can make this bigger. Yeah, you can see around 0.6 on YOLO V8. Okay, how about this now? All right. So this like, okay, good. All right. And that's what it is. Okay. How about this? Let's see. Yep. There you go. That's correct. And last one. Yep, that's correct. All right, let's stop this. So, all right, let's just think for a moment what we have done here. Like what has actually happened. So we started off, we have our OpenMV cam connected to our NRF 9160DK board, connected over UART. And then the NRF board triggered the OpenMV RT1062 cam or MCU to take a snapshot, to snap an image. And then this image was transferred over UART to the NRF card. And then by using and leveraging Golioth, we could use over LTE-M and CoAP, by using CoAP protocols over LTE-M, we could then blockwise transfer this image up to Golioth. And then by using these pipelines here, we could then forward this image from Golioth to our S3 bucket. And then what can happen there is that you can then build up this large data set with your edge devices with no physical access. They can be in hard to get areas, and they can be anywhere. You don't even need physical access to start collecting data sets. So imagine you have several of your edge devices out, and that's at FLOX we have our devices out in the forest. They need to find the actual animals which we need to deter, right? So this way we can collect large data sets by leveraging Golioth and with our edge devices. So then we can collect this data set, and for this demo we use the Haggard data set, but it's in the end you can collect a large data set, as I mentioned, and then you retrain your data set, you retrain your neural network model with this new data set that you have gathered, and then when you have a significant and pretty good data set, you can retain your neural network. You can do the integer quantization of your model such that it can be loaded and run on your edge devices, on your microcontrollers with limited RAM. But okay, now we have this new T-Flight, but how do we get it back on the edge devices? Well, we use Golioth again, of course. So not only are we using Golioth for our device management needs, but also for our neural network model management. So we then, as I mentioned, by using the OTA updates, we can also not only transfer firmware updates for our MCUs, but we can also transfer our new updated neural networks. So we transfer this by using the OTA updates and CoAP blockwise transfer again. We sent our T-Flight file down to our NRF board using an OTA update. And then from the communication MCUs, the NRF board, we transferred this new T-Flight file over UART to our OpenMV card, and we ran inference locally on the edge device by using the awesome OpenMV RT1062 MCU, and we could get pretty neat, pretty cool performance on the small OpenMV cam. And that's basically how we at FLOX leverage and use Golioth for our not only our device management needs, but also for our neural network management needs. That's it for me. Thanks, guys.
That was an exciting demo from FLOX Robotics, and we're excited to see more from them. If you want to see more about what they're doing, go check out the Golioth case study about FLOX Robotics and read all about how they're using Golioth AI capabilities to enable wildlife protection. Now we're going to head over to Dan, who's going to talk about leveraging AI in the cloud.
Thanks, Chris. My name is Dan Mangum, and I'm the head of engineering here at Golioth. So far today, you have already seen how Golioth enables deploying artificial intelligence capabilities on highly constrained devices, allowing for low latency response to local sensor readings. This enables a wide variety of use cases, but there are fundamental limitations with running models on the edge. In many cases, performing inference in the cloud is preferred due to the access to more compute and larger models. Golioth pipelines make it dramatically easier to transform and route device data to any destination. Today, we are excited to bring the pipelines features we have introduced together to demonstrate how Golioth can be used as an instrumental component in leveraging cloud-based inference in your connected device product. Specifically, we are releasing examples for leveraging popular hosted inference platforms, including OpenAI, Anthropic, Hugging Face, and Replicate, within your pipelines on Golioth. These platforms enable you to easily perform tasks like object detection, audio transcription, and text generation for use cases from connected cameras to smart speakers. Importantly, many of these platforms also allow you to bring your own models, meaning that you can expand and improve models over time as you collect more data from your fleet. Introducing AI into your connected device product requires only a few lines of pipelines configuration, making it easy to get started without extensive machine learning experience. As your product evolves, you can progress to a more complex architecture. And as you iterate, new pipelines can be introduced without disrupting existing ones, meaning that you can try out a new model or service on a subset of your device data, routing the results to a dedicated staging area. But don't take my word for it. Let's look at how one of our existing customers, Heatr.ai, is currently using a cloud-based inference approach. I am now joined by Clive Penfold from Heatr, and Clive is a Golioth user and is building a company on top of Golioth, and we're honored to have you here today. Clive, I was wondering if, to start us off, you could just tell us a little bit about what y'all are building at Heatr and maybe how Golioth fits into that picture.
Yeah, so what we're aiming to do is to use a electric resistance hot water cylinder as a form of energy storage and in a distributed way. So basically a virtual power plant, which doesn't produce power, but stores power at set times. So in New Zealand, where we're based, quantity of hot water cylinders are mostly electric resistance. So we've got something like about 1 million electric resistance hot water cylinders. And they're currently used in a way to support the grid. So we have this thing called ripple control, which is not super common around the world, I don't think, but basically in winter when power is short of supply, they send through a ripple in the power lines to houses, and the houses have a special relay which turns the hot water cylinder off because there's such a huge demand. The result of that is that you get this peak load reduction, but you often end up with problems because A, people run out of hot water, and B, when you turn them back on, they're all starving and they all turn back on and demand some power. So there's actually a big problem in turning them back on as well. Our approach was to make each hot water cylinder into an intelligent and state-based kind of operation. If we have more intelligence about what a hot water cylinder state is in, then you can make a decision. What we have aimed to do is take a microprocessor to gather information about the hot water cylinder, take it into the cloud and gather information and build a profile of that, which is not that in itself. Grid connected stuff is not particularly exciting, but what we're doing with that information is we're incorporating it into other information about the grid. So we aim to include location-based data. So if you have a specific street which is experiencing kind of constraints, you could turn off maybe 5 hot water cylinders which don't need power. And the end result of it is that we aim to improve the efficiency of the hot water operation, absorb more of the kind of free energy or very cheap energy which is associated with solar. One of the problems is that they're typically there, especially in terms of solar, in the middle of the day when there's no load. So if you can actually absorb that, it means that stuff isn't turned off. We're using Golioth to extract that information. We use it in the cloud, make an inference, and then we send information back to Golioth to turn on or off and operate the device.
Awesome. And the microcontroller that you have at the hot water cylinder, how is that interfacing to, read data off of that system?
It's just got a few sensors. It's just getting sensors off the temperature, typical kind of data to gain an inference of how its energy and temperature are typically what we use to gain intelligence about the device. We were using a WSS to suck the information out once it got to Golioth, but we now use your pipelines to send it straight to Red Panda. So it's kind of a Kafka feed. It just goes straight through. So it's a much better implementation. And at the moment, because we are using some information from a separate kind of power meter, we actually have to combine those downstream. So we get that information. But at the moment, we're using Golioth to control our microprocessors so that we can have direct control of the information.
Absolutely. And after that data gets into Red Panda for streaming, you mentioned that y'all use machine learning to do inference on that data. What is the process like for gathering data to train those models and then perhaps improving those models over time? How do you run the inference as well?
Ours is less of an inference on the data and it's more of an inference. So we're more using a reinforcement learning model based on the state and the grid conditions. The data we get out of Red Pandas, we feed into the model. So we build a state model based on that and feed that into a model that's been trained on Stable Baselines 3. So it's a PPO model. And that gets a lot of the information from the grid. So at the moment, we're looking at power price and we're looking at solar availability, which could be read as wind or solar availability. So the availability of renewables and emissions. So we basically take those factors, we take emissions, price, and renewable availability, and combine those with the state of the device. And it looks forward over a long period of time. So it looks forward over a period of potentially 16 hours, and it automatically decides whether to turn on or off to try and minimize those 3 kind of states. What I really like about Golioth is the activity of the team and the forums. They were quite helpful. Unfortunately, the programmer of the firmware, and it's not my experience, my background's a mechanical engineer, but I'm not specifically have this background in IoT, but you have to do it when you're a small startup. We learnt, and one of the issues was that, like I say, you can write stuff in Arduino code and send it up, but it doesn't feel very deep. So I guess what I found with the SDK is that you had, with the examples that you guys have, it was actually quite easy to implement. I guess one of the issues was the ESP IDF, which is a less of an abstraction layer. And sometimes that side of it was harder for me. But the Golioth I found quite easy. It's quite understandable you're basically just sending up and down messages. And there's some great examples. So our device this is only part of what we're getting at the moment. And it's largely due to my hardware skills. But at the moment, we're collecting the power information and we intend to do that on the device itself at the moment. But we've got a separate power switch that is operated through the Golioth, but it sends back a separate feed of the voltage and the power consumption to Kafka, which we absorb into to our algorithm. So at the moment, we are largely just capturing some of the temperature and power information and sending that up through Golioth, and we're controlling the power through Golioth. It's been helpful just to have that layer of security and understanding about that sort of stuff, that we've got the secure stream, but actually it's the light DV state, the real-time operation that's been easiest to understand, the digital twin. So once the data comes into this point of view, we've got how much data is going through. Most of it seems to be going through to Kafka, and then we're sending stuff back. It's got device logs, which have been helpful for debugging. One of the issues, obviously, is stable data, and this one here is actually in a basement, and sometimes it cuts out. So the pipelines were very easy to set up. There's some templates out there, so sending it off to Red Panda was quite easy. There's some secrets that need to be set up, but the rest of it's really just setting up your broker and the source of the data that you want to send through. So for us, it was really just filtering, injecting the metadata so that we get basically time and the device information, and then sending it straight through Kafka. And that's where we do all our processing. We were capturing this before using a web server, which basically ran a WSS client and sucked the information out, but that was intermittent and it had its own problems. So this is a far simpler and better process for us.
Now that we've learned about how to leverage AI models on Golioth, I'm going to hand it over to Dylan to talk more about ingesting training data and using it to develop models.
Thanks, Dan. Hey, everyone. I'm Dylan Swartz, Head of Products here at Golioth. I'm excited to show you how Golioth and some new partners enable streaming training data to develop AI models for IoT. If you've been following our journey, earlier this year, we introduced pipelines, a powerful set of features that redefines how you manage and route your IoT data on Golioth. We've touched on pipelines a bit already today for running AI models in the cloud, but I'd like to dig a bit deeper and focus on how you can use pipelines specifically to train AI models. At Golioth, we see that training data for new AI applications is trapped in the physical world. Generative AI is all the rage right now and has advanced to the point where it is today because of the vast amount of training data available out there on the public internet. That's not the case for IoT. And our mission here at Golioth is to empower teams to extract that valuable data from their IoT devices and route that wherever it needs to go, especially those locations needed for training new kinds of AI models that solve real physical world problems. And that's where pipelines come in. Pipelines allow you to stream, transform, and route data to any cloud destination, ensuring that data is processed and able to be used universally. And today, I'm excited to announce a new class of pipelines destinations, object storage. 3 new pipelines object storage destinations are available today: AWS S3, Azure Blob Storage, and Google Cloud Storage. And these are perfect for AI IoT applications that utilize images, audio, or even short video clips. These new destinations are great for handling data, specifically for training AI models, ensuring that your training set is always up to date with live data from in-field devices. Our firmware SDK has also been updated with support for blockwise uploads. This new capability allows for streaming larger payloads to the cloud over that same secure DTLS CoAP connection used for streaming sensor readings or your OTA updates. We think this unlocks tons of potential for new AI-enabled IoT applications, from AI-connected cameras that can stream high-resolution images for security or wildlife monitoring, quality inspection, and more. Audio-based applications can stream audio for voice recognition, sound analysis, industrial machines, and more. And at the beginning, I also mentioned a new partnership. And today, we're excited to announce our official partnership with Edge Impulse. By connecting Golioth directly to Edge Impulse via pipelines, you can train AI models specifically optimized for microcontroller class devices. To showcase the power of this partnership, I'm excited to introduce Owen Jordan from Edge Impulse, who's going to be giving a demo. Hey, Owen, welcome. Can you introduce yourself and tell us a bit about your role and Edge Impulse?
I'm Owen from Edge Impulse. I work in developer relations, and my role is to create and work on documentation and workshops And over the last number of years, been working with yourselves and excited to see this partnership coming together today. And Edge Impulse is a edge AI deployment and creation platform. So we enable our customers and community members to be able to create machine learning algorithms and deploy those to devices across a range of hardware and even some software deployments as well, like Docker. Today, we're going to be looking at Zephyr primarily deployment with yourselves, and very eager to work on this example that we can show real value.
Owen, why don't you give us an overview of how the Golioth and Edge Impulse integration works?
So for our demonstration today, we're showcasing the integration to both the data acquisition side, where we're collecting data from our device that's connected to the Golioth platform directly to our S3 bucket. And also we're demonstrating the integration here for our ingestion, where we're able to connect directly to our platform. We're able to run and build and deploy our Impulse to the Golioth connected device. So this is very important. We've got our data acquisition on the left that we can show our integration. And we've also got our deployment side here. So we're showing both ways that you can connect to your device, and you can apply your data quality transformation blocks on the left side here, which is connected to our S3 bucket. So we can process that data that's been streamed up to the S3 bucket. So I think right now the data is being streamed up as raw accelerometer data, and then we're going to pre-process that data and change the format to an acceptable format for our project ingestion. But other functions can be performed at this stage as well, like our data quality ones. And this is part of our enterprise suite of product features as well, these transformation blocks, and the utility that ML engineers will like to see. And so now we've demonstrated both of those connections. I'm going to switch over to my slide here, which is our active learning loop. As we said already, once your model has been deployed to your device, that isn't the end of the story. There can be unanticipated factors. There can be model drift. So you could have an environment that you didn't account for. You could have classes that you want to be able to detect for, like different types of conditions for your industrial IoT machine, or you could have collected more data, more relevant data than what was used in your initial data set. And being able to seamlessly integrate with platforms like Golioth and demonstrate some of these real world use cases and life cycles for these types of use cases is invaluable for our customers and for your customers as well that want to pursue AI deployments.
It's awesome. So you have this like active learning loop of deploying the model, getting more data, training the model again, deploying it back to the device, and continuously improving.
Yeah, so you can think of it as anyone who's familiar with continuous integration or continuous deployment. Same kind of scenario can be thought of as for your device. People might think of a TinyML. You can run these models completely disconnected, and they can go off into space on a satellite or to the bottom of the ocean. But in real world scenarios where you've got industrial machines that are connected, or if you've got a deployed wildlife camera out in the field, that you want to be able to detect new types of animals that have been captured with the deployed device, then when you do have connectivity, it's invaluable to be able to use that.
I'm curious, seeing all these different use cases of AI and IoT, are there any top use cases or favorite use cases you've seen recently?
Two of the main streams that we see, pillars that we see, are in human health and machine health. So human health will be the likes of wearables and non-medical devices for activity tracking. But the case that we see with Golioth and IoT integrators are more in the industrial sector, where we've got industrial IoT, predictive maintenance and monitoring, where we want to be able to assess the health of a machine rather than a person. So yeah, I guess some of the examples that you have in your case studies, like the power monitoring examples using Modbus and different industry standard protocols, are perfect examples that we can look at use cases for applying our machine learning algorithms to detect faults as they happen and prevent failures.
Without further ado, Owen's going to give us a demo of Golioth and Edge Impulse. So Owen, why don't you tell us a bit about what we're going to see here in the demo?
Yeah, thanks, Dylan. Today, right now, we're going to see a live stream of some accelerometer data that is coming through the Golioth platform from a NRF 91. I think it's a Thingy 91 that's connected on Dan's table, and it's streaming accelerometer data and inference results to our Golioth platform. So right now we're going to take a look at a running impulse that has been deployed to our device, and the impulse is created to be able to detect movements through the accelerometer. So when a movement is detected, either a snake movement, a wave, up-down movement, then the confidence score from that impulse that is running on the device can be sent to the Golioth platform with this demonstration that we're going to do right now. So I've clicked on one of my devices, I've selected it, and I can see here, if I look at my LightDB stream and I turn on auto refresh, I'm going to start to see some of these results that are streaming in from the deployed device. And this is happening in real time, so we can just see that some snake movements we can see the snake movement is being attempted on the desk. And let's see if we can see this snake movement is being detected by our deployed impulse. What we're seeing here are the different classes and the confidence scores that are being returned from the inference that is run by our model. So this can detect between 0 and 1, 1 being the most confident. And we can see here that we're not getting a very good result. So let's see. So this data is being streamed to the Golioth platform through our pipeline. Let's take a look open in the pipelines. So our accelerometer data S3, we'll take a look at this one first. So this is streaming data directly to a shared S3 bucket that can be processed later and used for training data in our Edge Impulse model. And if we look back at our classification results as well, now we're going to switch over to the Edge Impulse platform where we can see our Golioth organization and we can see our motion recognition project. You can just see here that we've got our Golioth organization, and we can see that our data is being collected to our S3 bucket, and we can perform on a nightly schedule. We can perform some data pipelines here as well if we wanted to be able to pre-process and perform some data quality steps. So right now, we're just going to work with the data that's being collected directly to the project, and we're going to see that we've got our data acquisition. We've got data that's streaming up with our labels, which is our wave, up, down, snake, and we can see the accuracy that we're getting as a result in our model. We can retrain our model, and then we should see an improvement in our model. So in our motion recognition project, the deployed version of our model was performing poorly because that was saved at 94% accuracy. And we can see here as well that the description, I didn't really need to add this here because we show the testing accuracy and the number of samples. So if I increase the number of cycles, then I get a better accuracy. And we found that we increased it to 300 cycles here, we were getting 100%. So we could collect more data, which is what we were doing. We were collecting more data, and that was streaming directly up to our project. And we can retrain our model with that data that has been collected. So we go to classifier here, I can start training. So we should see an increase in the accuracy then of our model. We can see now that with our 300 cycles, our 300 training cycles, we've returned to our 100% accuracy. Now we can very easily go to our deployment. We can choose our C++ library, and we'll just hit build, and we'll end with our C++ library that can then be packaged and deployed as firmware with the Golioth platform. Now we've got our C++ library that's been packaged. We're going to move over to the Golioth platform, and we'll try to deploy this as an artifact and cut our new release. We can see I've got our 1.1.0 version of the C++ library already available. You can see what's in the field, and it's 1.0.0. So if we create a new release, and that release is going to contain our 1.1.0. And the tag that it applies to here for the devices that are in the field is the demo tag. And we're going to start the rollout and create a release. So now that we've deployed our version 1.1.0, we can take a look again at the devices. So if we bring up our devices here, go into my project, devices, and LightDB stream. I'm going to turn on the auto refresh again in real time. And now as the snake movement is being performed, we should see some better results. So now we can see that we've got our 85.85 confidence that it was a snake movement. And is there an up-down movement happening? Now up-down is happening. And much better results are in the confidence score. And that should demonstrate the value in OTA. So when your model or impulse has been deployed to the field, the story isn't finished. You need to iterate and collect more data, improve your model, because you could have model drift, or you could have unanticipated factors, like we were just discussing about. You could be at an event, and there could be different types of interference happening at the booth or at the location that you're trying to detect, or maybe you didn't consider another movement that you wanted to be able to detect. Let's say in a real world scenario where you're trying to do predictive maintenance, and you have some of these motions that are associated with conditions of a motor, and there's a new condition that you want to be able to account for, then you might want to add that. So you can use this demonstrated architecture that we have seen today, how we can stream up our data to the S3 bucket seamlessly, and that data can then be used to create a new model and deploy it out to your device that's in the field using this OTA architecture and integration that we've demonstrated.
Thanks, Owen. Getting to see the full active learning loop, streaming live training data from Golioth, retraining that model, and then deploying it back down to devices over the air really shows how powerful and easy it is using Edge Impulse. I'm really excited to see what kinds of AI the Golioth and Edge Impulse communities train next. And I think that's it for this section on training. We've covered pipelines, our new blob storage destinations, blockwise uploads in our firmware SDK, and then finally the partnership with Edge Impulse. To wrap up, I'll hand it now back over to Jonathan. Jonathan, over to you.
It's so exciting to learn how much AI and IoT is contributing to making the world a better place, from saving endangered animals to sustainable utilities and more. I'm very excited to see what you'll build with Golioth for AI. Right now, through October 31st, we're offering a great incentive. For new paid customer accounts, we'll give you a $1,000 credit. And if you add AI, we'll toss in another $1,000. Plus Replicate will be offering a $500 credit for new customers coming from Golioth. Thank you for tuning in. Build on.